Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Alright, so very welcome to all of you. Welcome to textbook.com again. So टेक्स्टबुक पे आपका दोबारा स्वागत है. So आज के सेशन में बेटा वी आर गोइंग टू स्टार्ट प्रॉपरली विद थ्योरी ऑफ मशीन. आज के सेशन से एज वी हैव डिसाइडेड, सो आज के सेशन से वी आर गोइंग टू स्टार्ट प्रॉपरली थ्योरी ऑफ मशीन एंड वी विल गो इन द पैटर्न. We'll follow the pattern. Okay, हम pattern follow करेंगे. So we'll be starting one by one. Okay, what we are going to do? We are going to start with the very first topic and we are going to see a lot of very good concepts out of it. So before I start the topic, I would like to request you to please like and subscribe the channel. ठीक है, प्लीज़ चैनल को लाइक करिएगा, सब्सक्राइब करिएगा. ठीक है, प्लीज़ डू लाइक एंड सब्सक्राइब द चैनल. टेक्स्टबुक.com के गेट चैनल को आप प्लीज़ लाइक करिए, सब्सक्राइब करिए. ठीक है, थोड़ा सपोर्ट करिए हम लोगों को, है ना. एंड वी आर गोइंग टू गिव यू सो मच गुड कॉन्सेप्ट. हम आपको बहुत सारे अच्छे कॉन्सेप्ट देंगे. राइट बेटा, राइट. सो डेफिनेटली हम आज से स्टार्ट करने जा रहे हैं एंड दिस सीरीज इज गोइंग टू हैपन फॉर द नेक्स्ट 3 months. 3 month लगातार हम इस सीरीज को लेकर के आगे बढ़ाएंगे. तो सर सबसे पहला टॉपिक होता है हमारा थ्योरी ऑफ मशीन का सिंपल मैकेनिज्म. ठीक है, सिंपल मैकेनिज्म. नाउ बेटा किसी मैकेनिज्म को बनाने के लिए, मैकेनिज्म क्या है इसको लोग कई नामों से जानते हैं. कोई लिंकेज बोलता है, कोई कुछ और भी बोलता है. ठीक है, सो बेटा हमारा जो मैकेनिज्म है, द मैकेनिज्म व्हाट वी आर गोइंग टू टॉक अबाउट. तो फर्स्ट ऑफ ऑल वी नीड टू टॉक अबाउट दिस that from what mechanism is being formed. क्या चीज से मैकेनिज्म बनता है. तो फर्स्ट ऑफ ऑल वी नीड टू हैव अ लिटिल इंफॉर्मेशन अबाउट दिस. हमें थोड़ा सा इसके बारे में इंफॉर्मेशन लेना है. काइनेमेटिक लिंक और एलिमेंट. राइट, ठीक है, बिकॉज अ मैकेनिज्म विल बी फॉर्म्ड यूजिंग नंबर ऑफ लिंक्स. एक मैकेनिज्म जो होता है वो कई सारे लिंक से मिल करके बना होता है. तो सबसे पहले बेटा, सबसे पहले व्हाट वी नीड टू डू, वी नीड टू अंडरस्टैंड व्हाट डू वी मीन बाय अ काइनेमेटिक लिंक और एन एलिमेंट. इससे हमारा क्या मतलब होता है. तो लेट्स डिफाइन इट. सबसे पहले इसको डिफाइन करते हैं. सो अ काइनेमेटिक लिंक और एलिमेंट, तो इट इज, सो कैसे कह सकते हैं. सो एनी पार्ट ऑफ अ मशीन which has some relative motion with respect to the other parts of the machine, ठीक है. तो सर आप अब मशीन की बात कर रहे हो, अभी तो आपने हेडिंग लिखी है मैकेनिज्म. तो बेटा मैकेनिज्म एंड मशीन में क्या डिफरेंस है. व्हाट इज द डिफरेंस बिटवीन मैकेनिज्म एंड मशीन. सो वी आर गोइंग टू एक्सप्लोर इट. वी आर गोइंग टू हैव इट एक्सप्लोर. डोंट वरी अबाउट इट. हम पूरा एक्सप्लोर करेंगे. ठीक है, पूरा एक्सप्लोर करेंगे. डोंट वरी एट ऑल. ठीक है, बिल्कुल चिंता करने की जरूरत नहीं. वी आर गोइंग टू टॉक अबाउट ईच एंड एवरीथिंग. ऑलराइट. Now, the first thing here is the definition of the link, that any part of a machine which has some relative motion with respect to the other part of the machine. So, what is the most important thing in this definition is this word, relative motion. Is this word relative motion. देखिए यहाँ पे जो सबसे important शब्द हमने use किया है, the सबसे important part of this definition is your relative motion. Getting my point, बेटा? Getting my point? Now understand. What do I mean by it? So I want to ask, see, in the first chapter, there are so many questions of degree of freedom, ratio of law. Now to understand those questions, now to attempt those questions, it is very important that we understand the link first. Otherwise, we won't be able to do it. ठीक है, हम फिर कर नहीं पाएंगे, हमको प्रॉब्लम होगी. एंड डू लेट मी नो इन द चैट इफ देयर इज अ डाउट. ठीक है, चैट में मुझे बताइएगा जो स्टूडेंट लाइव पे है. So I am seeing your chat continuously. So please tell me अगर कुछ भी doubt होगा, कुछ भी पूछना चाहेंगे, कुछ भी बताना चाहेंगे, तो please feel free about it. Now I want to ask you something. So what is this? What is this? If I ask you this, that what is this? ये क्या चीज़ है? तो डेफिनेटली आप कहोगे कि सर दिस इज अ कैलकुलेटर. डेफिनेटली यू विल से दैट दिस इज अ कैलकुलेटर. ओके, यू हैव टू रिस्पॉन्ड. ओके, नाउ दिस, व्हाट इज दिस? Sir, you would say, sir, this is the cap of this is the cover of this calculator. Now, if I ask you, will you ever call this calculator a cover or a cap or something? I would say no. Yes or no? I know that we are smart students, so we never will say, good evening, Vishnu, very good evening. So we will never say this calculator, as a cover. Now, similarly, if I ask you what is this, so you will always call it a cover, you will never call it a calculator. Now, what I mean to say is, now it is very simple thing to understand that these two are certainly two different bodies. This is a calculator, this is a cover. No person having a good state of mind will call this thing a cover or call this thing a calculator. So 100% with 100% guarantee we can say, with 100% guarantee what we can say, with 100% guarantee what we can say, with 100% guarantee we can say this, that these two certainly are different bodies. Now if I attach them, if I join them, if I assemble them like this, if I assemble them like this, if I assemble like this, so can I say, sir, कि sir, this is the assemblage of two bodies, a calculator and a cover. Now, is it okay or not? Please tell me. क्या ये बात ठीक है? Is it okay or not? Can we call this thing a assemblage of two distinct body, a calculator and a cover? But can we say this is the assemblage of two different links? So this is no two different links, but it is the assemblage of two different bodies. It is the assemblage of two different bodies. Yes, Vishnu, we are calling it a cover. Okay, so we are now assembling the calculator and the cover. So definitely this is the assembly of two different bodies. But is it two different links? Now I want to ask you, is it two different links? So the answer should be no, sir. These are no two different links because there is no relative motion between them. Wherever this calculator is going, at whatever speed, at whatever direction it is going, sir, the cover is also following it. So there is no relative motion between them. So these two are two different bodies, but these two are not two different links. Now what I tried to teach you here, what I was trying to, Vishnu, this is English only, isn't it? This is English only. What do you say? I am speaking English only, beta. I'll sometimes mix up so that other students can also understand now. Okay, but it is mostly English. 99% I am English I am using, isn't it, my dear? So definitely these two are different bodies, but these two are not different links. Why these two are not different links? Because there is no relative motion. Because there is no relative motion between the bodies. Okay. So now can we say, sir, this is the relative motion. It is the deciding factor. It is the thin line. It is the difference. It is from which we can understand the difference of a link and a body. Now, is it okay or not? Please say yes or no. This example is clear. What is the difference between a mere body and a link Please tell me, my dear. Please answer. See, you have to respond. Right? So now, what I was trying to do, I was trying to tell you the difference between the link and the body. Now, if I ask you this, so I hope many of you must have read theory of machine to some extent before also. Sir, semester we do it in semesters also. We see it in semesters also. So, sir, have you ever seen this figure? Definitely, any mechanical engineering student who have completed his BTech or his end-up process, then definitely he must have seen this figure. This is known as a single slider crank mechanism. You generally call it a engine or a compressor. Now I want to ask you, what are the links here? Can you identify the links for me? Can you identify the links for me? How we can identify, sir? So we can identify on the basis of relative motion. We can identify on the basis of relative motion, right? We can identify on the basis of relative motion. We can identify on the basis of relative motion. Yes or no? Yes or no? By the definition we just have seen, sir, by the relative motion we can do it. Now, so this is something we call it a cylinder. Inside the cylinder we got a piston. Inside the cylinder we got a piston. Now this is my connecting rod. Now this is my connecting rod. This is my connecting rod. And this is my crank. And this is my crank. Getting my point, better? This is my crank. Alright. This is my crank. Now, do we know this, that the piston reciprocates? So I hope all of us understand this. Piston reciprocates inside the cylinder. Now I want to ask you, if piston is reciprocating inside the cylinder, it is sliding inside the cylinder, do it have a relative motion with respect to the other parts of the machine, which is obviously cylinder, connecting rod and crank? Can you please answer me this? Acha. So you are a first year student, Vishnu. Okay, so I'll tell you the basics. No issues. So my dear, this is something. So it is an engine basically. It is an engine. So you know the engine. What engine does, beta? We are surrounded by the engines, aren't we? We are surrounded by the engines only. Now, in an engine, what happens? Overall, what you know about the engine? Do you notice that in the engine, we are providing some input, like we are driving the motorcycle, so we put petrol into it, and by the burning of that fuel, we create some power, and we get ourselves moving. Do we have this information, my dear? What do you say, Vishnu? ये information है आपके पास? Do we have this information, my dear? I hope yes. I hope yes. Now similarly here, so what I was saying, so it is the basic arrangement. So we have a cylinder. So we are making it in 2 dimension. Okay? We are making it in a 2 dimension. Vishnu. We are making it in 2 dimensions. Getting my point, beta? Getting my point. So, when we are making it in 2 dimensions, so this is a cylinder. Cylinder we know na, a hollow thing. In this hollow thing, there is a piston. Piston is the one which slides inside a cavity. Okay, that is what we call a piston. That is what we call upon as a piston. इसको हम बेटा piston कहते हैं. Getting my point बेटा? इसको हम piston कहते हैं. Okay? Okay, इसको हम piston कहते हैं. So if you are not able to understand me, can you see this 3-dimensional figure, my dear Vishnu? Can you see the 3-dimensional figure? So this is what I was showing as a cylinder. Now if I have to make it in 2D, I would make it like this. मैं इसको ऐसा बनाऊंगा. I would make it like this. I hope you are getting the point now. Right? So inside this hollow cylinder, this is the piston. This is the piston which slides. So it is moving like this. It is sliding. It is moving like this. Now this is the connecting rod. Now how it will move? We are learning thermodynamics also on the channel. The channel is very, very useful. So kindly share it also. Right? Now if this is the piston, so when we see this a piston, so how this piston will reciprocate? Sir, we have named it piston, so it will reciprocate. It won't happen. Okay? We are knowing the first law of thermodynamics. क्या लेके आए थे, क्या लेके जाओगे? Yes or no? First law of thermodynamics. So without giving anything, you are not going to get anything. right? This is broadly the first law of conservation of energy. Unless you provide some other form of energy, you cannot create the mechanical energy. Now, so what is there? So some fuel will burn inside this, some fuel will burning happen, and the burning of that fuel will exert some pressure on the piston, and this piston will be in moving condition. Then piston will then be moving. Understood? Now, when this piston is moving, you see this is structured connecting rod. Now, in 2D, it can be represented like this. So, in 2 dimension, we are representing it by a line like this. Getting my point? So, now, when this piston is reciprocating, it will definitely push the connecting rod. I hope you can imagine this. I hope you can see to it. So, when this connecting rod will be pushing this, when this piston is pushing this connecting rod will do oscillation. Oscillation is what? To and fro motion. Okay. So this connecting rod is now start to oscillate. Now I want to ask you this. Now since piston is reciprocating, does it have relative motion with respect to the other part of the machine? And this is the crank. Which rotates. Now, when the connecting rod pushes this thing, so you can see from here, it is exerting some pressure. Some force on it, and it will make the crank to rotate. So, in 2 dimensions, we are making this crank like this. So, this crank is doing what? It is rotating. Now, if I see the piston, now according to the definition, my dear, if I see the piston, अगर मैं piston को देखूंगा, if I see the piston, so my piston is seen to be reciprocating. Now, since the piston is reciprocating, can we say it has relative motion with respect to cylinder, connecting rod, and crank? What do you say? My student? What do you say? Please tell me. Answer me. See, you have to answer me, and please share also. चलिए बताइए. So now piston is definitely having different sort of a motion when compared to the other parts, which are obviously cylinder, connecting rod, and crank. Now we can see that piston has some relative motion, so we can distinguish it as a link. Now similarly, this connecting rod is what? This connecting rod is oscillating. So certainly this part of this machine is also having relative motion with respect to the other part of the machine. So this is also one link. This is also some link. Now this crank is rotating. When this crank rotates, my dear, जब ये crank rotate कर रहा है, when this crank is rotating, so since crank is having the rotation here, so when the crank is having a rotation, when the crank is having the rotation, so can we say that it is also having relative motion with respect to other parts of the machine? So we can name it 4. Now when we say relative motion, my dear, relative motion, so relative motion, can we say cylinder is also in relative motion with respect to other part of the machine? Now, sir, how cylinder you are saying it is fixed? Cylinder is something fixed. So let me tell you. So let's say there is a man standing here and another person with a cap, let's say. So it is moving. So he is fixed. He is standing here and he is moving in this direction. Now, with respect to person number 1, person number 2 is in relative motion. Yes or no? With respect to person number 2, person number 1 is in relative motion. This is what we mean by relative motion. We very well know, we have solved this kind of a problem. Our train is going from the platform. Did we or didn't we? Did we or didn't we? A train is going from the station. A train is moving from the station. A man is standing. How much time it will take the train to cross that man? As a type of question. There we understand the concept of relative velocity, isn't it? So something is fixed and some other parts is moving. So the fixed part is also in some sort of a relative motion. Now please remember beta, in theory of machine, here goes the tip number 1, here goes the tip number 1, here goes the tip number 1. So always when we number it, see, it is very very necessary that you number the links correctly. Otherwise you will not be able to solve the question of degree of freedom, velocity analysis, acceleration analysis. None will be clear to you. So it is very very important that you understand a link and you denote it well. Okay. Now since cylinder is fixed, so we are saying we have named the fix as a number 1. Always give fixed link number 1. Now this is also fixed. Now this is also fixed. So I can say this cylinder and this pin, I can say that this cylinder and this pin, since both are fixed, they do not have any relative motion between them. So they will constitute the same, link. Bolo yes or no? Say yes or no on this. Please respond in the live, students. Please respond. So if I say the spin and the cylinder is same link because they have no relative motion. Now consider that there is some person, let there be a person, we have tied him up on the crank and that person is rotating with the crank. Now kinematically, now please understand this, the concept is, so kinematically means in terms of motion, there is no difference between that person and the crank because that person is also rotating in the same speed, in the same direction as of that crank. Getting my point? So for relative motion to occur, for relative motion to occur, either velocity should be different, magnitude should be different, या तो magnitude different होना चाहिए, velocity magnitude should be different, और directions or direction of velocity may be different or both are different. Now to relative velocity, for relative velocity to exist, both are different. So for relative velocity to exist, obviously any one of this should satisfy. Either there is a difference of velocity, either there is the difference of direction, or either there is a difference of both magnitude and direction. Okay. Also there can be the difference of the type of motion. Also there can be the difference of the type of motion. As we can see in this piston cylinder arrangement, difference of the type of motion. So as we can see in the piston and cylinder arrangement, all individual links are possessing different type of motion. Crank is rotating, connecting rod is oscillating, cylinder is fixed, piston is reciprocating. So definitely we can say that each and every link possesses a different sort of motion. So there is definitely relative motion and hence they may be named as a different links. Now I want to ask you something. So we can see this figure like this also. Sometimes it is managed, sometimes it is showed. It is being showed like this. Sometimes it is also being showed like this. कई बार ये ऐसा भी दिखाते हैं. Sometimes it has been shown like this. So it is like this, beta. It is like this. Okay. So now, if we want to do it, so we have seen this one. Right? So we can make another figure. No worries. So we can make it like this. So sometimes this figure is also presented like this. Okay. So you can see something extra here. Rest are the same, rest arrangement is same, but some things are extra. So this is called as cylinder. This is piston. This is piston rod. This is my piston rod. This is the connecting rod. This is the connecting rod, and this is the crank, and this is the crank. Now what you have to do, you have to tell me. Now you have to tell me, my dear, you have to tell me what are the different links in here. What are the different links in here? You have to tell me what are the different links in here. यहाँ पे क्या क्या different links हैं? What are the different links in here? Can you calculate me? Can you distinguish the link for me? Please go ahead. Please attempt it and let me know. Please attempt it and let me know. Please attempt it and let me know. Please do it. Let's see if we can do it or not. Please identify me the links. Please identify the links for me. Can you please identify the links for me? Can you please identify the links for me? So yes sir, we can. So to understand the number of links here, what we can do, so first of all we need to see the motion. So this piston reciprocates, this piston is sliced, this piston rod also is sliced, and it is sliced in the same way, in the same direction, with the same velocity of that of piston rod. Again sir, this connecting rod oscillates, and this crank rotates, and this crank is rotating. Now if I have to number the links, so as I said, always call the fixed one as link number 1. So this is fixed, so this is link number 1. This is also fixed, so this is also link number 1. Now this piston is reciprocating, so it can be called as link number 2. Now since the piston rod is also reciprocating, now Vishnu, here you have made the mistake, my dear. You are saying sir 5 links. Now my dear, as we were speaking about it, so piston and piston rod both have the same velocity and same direction. So will there be any relative motion between them? Will there be any relative motion between them? So no, since they are having the same velocity, they are moving in the same direction. So piston rod combinedly will constitute link number 2. Is it understood or not? For links to be different, there should be relative motion. Now there is no relative motion. I hope all of us are understanding this. So since there is no relative motion between piston and piston rod, so they both will constitute same link. Now we talk about the connecting rod. If we talk about the connecting rod is oscillating. Connecting rod is oscillating. So definitely it has some relative motion with respect to other parts of the machine. So this crank is rotating, so definitely it is having some relative motion with respect to other parts of the machine. So again we have 4 links only. Yes Vishnu, you have made the mistake, my dear. आपने mistake किया था. You have made the mistake. Now I think you have realized it. So whenever we are making the distinction, whenever we are seeing the links, what we need to do, we need to focus upon the relative motion. So any bodies which have the same relative motion will constitute the same link. Now concept is taken or not? What do you say? So any body having the same motion, when there is no relative motion, they will constitute the same link as this piston and piston rod are making the same link. Now let's see this one. So we also have a cam and follower arrangement. So let me show you a cam and follower arrangement. So sir, now I hope we are also realizing it. Now I hope we are also realizing this, that's for identify the links, we must have the information regarding their motion. we must have the information regarding their motion. So this is the cam. This is something we call as cam. So sir, what cam do, sir? Sir, it generally rotates. Particularly in this figure, it rotates. Okay, it rotates. So cam is rotating. Now if I say follower, this is your follower. So this follower reciprocates. This follower is reciprocating. This follower is reciprocating. So it reciprocates. The follower does what? Follower reciprocates, right? And this is the guide. This is fixed. This is fixed. Okay. Okay. So this is the representation of something being fixed. This is the representation of something being fixed. Now, can you give me how many number of links are there? How many number of links are there in this arrangement? So where cam and follower is being used? So cam and follower is being used for governing or managing the valves. So we know now we have valves in industrial purpose also. We have valves in vehicles also. Now to operate the valves, we apply mostly cam and follower arrangement. Now can you tell me how many links are there? Please identify the links for me. Please identify the links for me. Please identify the links for me. Very good, Vishnu. So there are 3 links only. There are 3 links only, my dear. There are 3 links only. So, sir, the fixed one, we will call it the fixed one as a fixed. So wherever it is there, the fixed one, so we can number it. Okay, so whatever is fixed, we'll call it as number 1 wherever we see it. Okay, so this fixed thing is your link number 1. Now since cam is rotating, this is link number 2. It is having some relative motion with respect to other parts of the machine. And sir, follower is reciprocating. So follower is reciprocating, that means follower is also having some relative motion with respect to the other part of the machine. So this is also a link. Now I want to ask you this. So if spring is there. So we got a spring here. So is it a link differently or not? Is it a different link or not? This spring is a different link or not? Can you tell me? So no sir, this is not a different link. This is link number, this will be known as link number 3 only. This will also be a link number 3 only. Why it is a link number 3? Why it is a link number 3? Why it is a link number 3? So it is link number 3 because it is having the motion very much similar to. It is having the motion very much similar to that of the follower. It is having the motion very much similar to that of the follower. Now, please tell me, will you be able to identify the links correctly? Will you be able to identify the links correctly? Can you please answer me? That? Will you be able to identify the links correctly or not? Please answer. Please answer me. बताइए, जल्दी बताइए. My dear, the purpose of finding the link is because we are learning this theory of machine. Okay. Now definitely the theory of machine we are learning. So we are interested in understanding the machine. हमें machine बनाने में interest है. We are interested in making the machine. Now that machine will not be made up of like air. It will have some components into it now. like the machine we are seeing, engine. So in engine we have cylinder, we have piston, we have connecting rod, we have crank. Okay, so we are identifying them separately so as we can lead to making of a machine. Okay, so in the future, in some time, maybe not in this session, till now I have not introduced you with this machine. Okay, because to make machine we require to explore firstly from which the machine can be formed. Getting my point, beta? Anything if we have to make, it is made up in parts now. If I show you my mobile, this is my mobile. So this is mobile is also made up of so many things. Okay. Okay. So why, sir, we are seeing each and everything alone? So as we, when we join them, when we relate them, we'll be able to understand. Second reason is, my dear, very, very bluntly. So because when you see a question in a gate examination, if you are not able to count the link correct, you will be losing your 2 marks. In the last session, when I started with theory of machine, I told you the margin of this first chapter. In this first chapter, average marking I showed you in the last session, so it was almost 2 marks. Okay, so when you find the 2 mark question, unless you know the links, how to differentiate the links, you won't be able to count them and you won't be able to solve the question. Now I want you to identify the links for me in this also. Now please identify the links for me in this also. Can you please identify the links for me in this? Can you please identify the links for me in this? So this is also actually a cam and follower. So this is not like this. So let's make a spring again. So let's make it a spring again. It is like this. So this is known as a roller follower. Now can you tell me what is the number of links here? Can you please tell me what are the number of links here? How many links are there? How many links are there? Can you please tell me, sir? This is cam which is rotating, this is follower, this is reciprocating, and this is the guide. Now can you please tell me what are the number of links in here? How many number of links are there? Can you please tell me? Please go ahead. Please go ahead with that. Please go for it. Please go for it. How many links are there, Vishnu? So now many of you are thinking that there must be 3 links. So no, beta. So let's count it. So this is 1, this is 1, this is 1, this is 1. This is also 1. Whatever is fixed, we can call it as 1. Okay, now this cam is rotating, so this will be 1 link. So let's name it 2. Now follower is there, sir, it is reciprocating, so this is 3. Now I want to ask you, so you can see a ruler here which is attached to this follower by a pin. So can this ruler also rotates about its individual axis? मतलब क्या ये यहाँ पे rotate कर सकता है? Can this ruler also rotates about this? बोलो. Now, since it is rotating, it is also having a relative motion, so this may be called upon as link number 4. So anything which have some different set of motion, different sort of a motion with respect to other parts will be called upon as a link. Now please tell me, can this ruler rotate about this pin or not? Can this rotate about this pin or not? Please answer. Please answer. Please answer me. Please answer me. जवाब दीजिए. Please answer. Please answer. So this can also rotate about this pinpoint. So when this can also rotate about this pinpoint, this can also rotate about this pinpoint. So definitely it is having some relative motion with respect to the other parts of the machine. With respect to the other parts of the machine, definitely it is having some relative motion with respect to the other parts of the machine. Hence, it is also a different link. So, what are the number of links here, my dear? What are the number of links here? So, here again we have the 4 links. So, now I want you to confirm me that we will be able to identify the different links in some arrangement or in some system. Now, do we agree to it or not? Please answer me. Is it okay up to this point? How to, very, very important concept. Many students get confused in there. Many students have lot of confusion in this, identifying the link. So when you are not able to identify the links, definitely you are not going to do the question properly. All right. Now please tell me. Now please tell me. Is it fine or not? So we understood this concept of identifying the links. We understood this concept of identifying the links, right? Right. Now let me complete the definition of it. So this is the first part of the definition. Now the second part of the definition is a link, a kinematic link must be a resistant body. A kinematic link should be the one which is a resistant body. So many times you will see 4 links. Yes, it is okay, Vishnu. There were 4 links. So now let me complete the definition. Now let me complete the definition of it. So a link must be a resistant body. What kind of a body? It must be resistant body. Understood, beta? Understood? Bolo. So you will see so many times this question in the examination. So what they are asking you. So a link must be, remember, a link must be. So they ask you this must be a solid body. This must be a solid body. It must be a rigid body. It must be a flexible body, or it must be a resistant body. So definitely what you are going to answer. So you are going to answer this one. Yes, a link must be a resistant body. Now, sir, what we mean by this resistant body? What do we mean by this resistant body? So if you have learned this strength of material subject, I hope you must know what is rigid body. So rigid body is something, now remember this, it is a body which do not deform, at all, no matter what is the force on it. So this is practically impossible that you apply any force on a body. You apply, no matter what large force you are applying, so you apply any force on the body and it do not deform at all. This is practically impossible. Getting my point? But if we try to know the meaning of rigid body, so rigid body is the body which do not deform at all, no matter what force you are applying on it. So there is no such body in the world. Now, what do we mean by this resistant body? Sir, what is the meaning of this resistant body? what do we mean by a resistant body? So what we mean by a resistant body, please understand this. So a resistant body is the one, a resistant body is the one which is able to transmit power and motion. So anything that has the capability, now please understand this, anything that has the capability to transmit power and motion from one place to another will be called upon as a resistant body. So a link must be a resistant body. That means any link must be capable of transmitting power and motion, like you see in the figures I have shown to you. The figures we have shown to you. So here in this figure, now piston is reciprocating. Now piston is reciprocating, giving its motion or transferring it to the connecting rod. Now due to the reciprocation, now since the piston is reciprocating, it transmits it to the connecting rod in the form of oscillation. So the motion of the piston changes to oscillation of the connecting rod. Now can we say this piston is transmitting some motion and power? Yes, certainly it is, sir. When it is sliding, it is pushing the connecting rod and make it oscillate and make the connecting rod oscillate. Agreed or not, my dear? Agreed or not? And make it oscillate. Right or wrong? Make it oscillate. Right or wrong? Definitely. So is the piston a link? Yes, it is a link, and yes, it is a resistant body. Similarly, connecting rod. So the motion of connecting rod is getting transmitted to the crank, due to which the crank start to rotate. Getting my point? So that is also the link. That is also the link. Getting my point or not? So any link with anything which is a resistant body which is capable of transmitting power and motion, we may call it a link. Now I think this resistant body is understood to you. Now remember my word, anything which is able to transmit power and motion, anything which is able to transmit power and motion, we call it a resistant body. Now since we understood the meaning of the link, so let us move to what are the different types of link. So हम क्योंकि link की definition को समझ चुके हैं, since we have understood the definition of link, I hope, so now can we move that what are the types of link we got in the world? How can the links be classified? So when we see something, when we decide something, when we define something, we also need to see that what are the types of it. So this type of links are, the first one is rigid link. Now I think with the example itself you will be able to realize what it is. So this is like crank, connecting rod. These are the example. Okay, do not confuse it with the definition of the link. It has nothing to do with the definition of link. It's just the classification. A link must be a resistant body, but when we are saying the rigid link, we are referring to the crank, connecting rod, piston, etc. Okay, which are transmitting the power from and motion. Also, if you judge it, if you see it with context to the other types of link, you will see that there is very small, there is very negligible, there is very small, there is very negligible deformation in these bodies, since they are very well solid body. Yes or no? Yes or no? Please answer me that. Okay. So when we talk any of the link about which we talked till now, piston rod, piston rod, two are the same link. Connecting rod, crank, cam, follower, this roller, whatever we talk about, they are all resistant bodies. And they are classified in the type of rigid link, since these are the solid bodies and there is almost negligible deformation is there. So how we are classifying it? Now the question is to remember this, how we are classifying it. So we are classifying it on the basis of deformation. on the basis of deformation. So when we are writing the type of links, so type of links we are doing on the basis of on the basis of so types of link, what types of links are there, so we can classify it on the basis of deformation. So if deformation is very less or negligible, we can call it a rigid link. If so, there is something called flexible link also. There is something called flexible link also. So what is this flexible link? What is this flexible link? So again, on the basis of the definition, again on the basis of the definition, again from the basis of this classification, from this definition. Now please understand this. Now can I tell you something? So please answer, have you ever seen this something like this? Have you ever seen something like this? Yes sir, this is the belt and pulley arrangement as we can see to it. This is the belt and pulley arrangement as we can see to it. Now if you observe the belt, so whenever we are reading some theory, now this is first few topics are theoretical. So when we are reading the theory, we have to relate that things. Now when we talk about the flexible link, so whatever we are talking, obviously we are talking in context to the other type of link. इस type वाले link में what happens? So इस type वाले link में what happens? In this type of the link, what is happening? So in that type of link, what is happening? So now please ask me. Now please answer me. Now we know this belt when we see this belt. Now first of all, I want to ask you something. This belt is a link or not? First of all, I want to ask you this. This belt is a link or not? So you would say certainly, sir, it is a link because we have seen it. We have seen it in the shops nearby. We have seen it when we go to drink sugarcane juice. गन्ने का जूस जब पीने जाते हैं. When we go to drink the sugarcane juice, we see the belt and pulley attached in there. In the bikes, we have chain kind of arrangement. Now, first of all, I want to ask you: is it this belt is capable of transmitting power and motion? So you must say yes, sir. It is able to transmit the motion of one shaft to another. It is capable of transmitting the motion from one shaft to another. So definitely, sir, it is a link. Definitely, sir, it is a link. So it is transmitting power and motion. So it is a link, my dear. So it is a link. It is a link. Getting my point? So it is a link. But if I see it in comparison to the other links, there is some flexibility in it, sir. How you are saying it? So, sir, if you go through Vishnu, these two pulleys are rotating at different speeds, my dear. These rotates at different speed because their size is different. So when the speed is different, there is relative motion. So how many links are there? How many links are there, my dear Vishnu? Abhi bhi link, you are not able to identify the links, number of links correctly. You are not able to identify the number of links correctly. Getting my point? Getting my point? Getting my point? You are not able to identify the links correctly. आप अभी भी लिंक को सही से correctly you are not able to identify it. You are not able to identify it, my dear. Why is this so? Now, do we agree to this that the pulleys rotates at different speeds? Say yes or no. My dear, yes or no, Vishnu? So when they oscillate, when they rotate at different speed, definitely there are three links. Now, but that is not the point here. So if I say, if you compare the belt with respect to this crank connecting rod piston, so certainly there is some amount of deformation in the belt. Do we agree to this or not? क्या लगता है? Do we agree to this or not? When we see the belt in context with or in contrast with the crank, connecting rod, piston and all, which are the solid bodies, so you can Imagine when you imagine a belt transmitting power from one pulley to another, you may imagine that this belt is having some flexibility, as it is having some tight side and as it is having some slack side. Now, do we agree to this or not? Please say yes or no. Do we agree to this or not? Agreed or not? I hope we are agreed to it. We are agreed to it. So now, on the basis of deformation, so it is having slightly more deformation when we are comparing with the crank connecting rod piston, which were in the category of rigid links, right? Now there is something called as fluid link also. Now there is something called as fluid link also. Now sir, what is this fluid link? Now sir, what is this fluid link? Now sir, what is this fluid link? So in our basic academic studies, have we seen this figure? In our basic academic studies, have we seen this figure or not? Please answer me. Yes or no? What do you say? So sir, yes sir, we have seen sir this figure. So we apply a small force here, and by this force, this weight can be lifted up, as we see sir in hydraulic, jack, pump, etc. Jack, screw, so many things are there. Agreed. Now this fluid, now please tell me, do you agree to it or not? You have to answer me. You have to answer me on this. So if this fluid here, can we say this fluid, is also a link? Say yes or no. This fluid is also a link. Can we say so or not? Please answer me. This fluid or oil, maybe whatever it is, but it is a fluid. Fluid is also a link here. Why? Why this fluid is a link here? Because I want to ask you this. Now, can you see this fluid is transmitting power from this place to another place? So whenever anything will transmit power and motion, whenever anything transmits 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 power and motion, what it can become? It can become a what? It can become a link. So here a fluid is also working like a link. Yes or no? Now, if we want to, fluid is link. Yes, Vishnu, fluid is link. Now, if I talk about the deformation, so fluid by its definition, if you are reading the fluid mechanics I think is also started on the channel. Please go and subscribe. Please watch all these things. These are absolutely free. No charges at all. Getting my point, Bida? Getting my point. No coaching is doing this thing. Giving the whole content. Most of the content is going to given for the free only. For your welfare. Now, what I require from you, first of all, please do share this. Please do share it with your friends. Okay? Please do share it. Please post it on your social media platforms. Please share it. Please subscribe it. Please do the comment in the video, because as much as student come live, that will be more interesting, because everybody will be sharing their doubts, everybody will be responding. So there will be some competitive spirit also, and that will help us in our preparation, and that will definitely help us in understanding the concept. So here, if I ask you what is the definition of fluid, what would you say? If you have to define the fluid, Pranshu sir has started the fluid also. Now, if we have to define the fluid, so what is this fluid, Vida? So fluid is something which continuously deform. By the definition of fluid, we can say fluid is something which is continuously deformed under the action of a slightest shear force. It is something which continuously deform under the action of its slightest shear force. That is why we say fluid is something which is flow. Fluid is something which flows, yes or no. Fluid is something which flows, yes or no, my dear. Yes or no? Now, if we see that by the definition of fluid, it is something which has so large deformations, but still it can work as a link because it is capable of transmitting power and motion. Now, hope it is fine. So, what can be the example of fluid link? What can be the examples of fluid link? What can be the examples of fluid link? So, fluid links can be hydraulic, jack, pumps, screws, etc. These are the example of fluid links. Getting my point, beta? These are the examples of fluid links. So I hope, beta, link and the type of links are completed, are clear to you, are clear to you. Now, beta, now I hope कि link and type of links आप लोगों को समझ में आ गया होगा. So my dear, I would show you something. ठीक है? Now at this point, I will take a minute and will show you something. So I am going to show you a promo. ठीक है? ठीक है? इस समय I think offer भी चल रहा है. There is some offer going on also. So okay, so we can do one thing. We can go and check it out. ठीक है? Gate to ME 2022 live coaching already begun. Okay, already have begun. So if interested or if we are finding the videos, finding the lectures good, so we can switch to the channel also. We can go to the testbook.com, we can find our courses. So every day what will happen, just after we complete that class, you will be given a practice set where there'll be the questions of this is a very important because I also have crossed this phase of preparation once in my life. So proper guidance is very much required. Getting my point? So just after we complete the class, you will get to do so many practice questions. So when you do those practice questions, definitely you are going to have benefits in your preparation. You are going to have the benefits in your preparation. So we can go and check this sometime. Okay, एक बार check करिए, वहाँ पर भी demo लीजिए and try to decide that. Okay, now let's come back to the point. So we have seen up to now the links, we have seen up to now the types of link. Now before moving ahead, I want to ask you this. Question. Before moving ahead, I want to ask you this question. So what would you say that in this definition of a link or element, in this definition of a kinematic link or element, which is the most important word here? Which is the most important thing you can observe in this? What is the most important thing you can observe in this? Can you observe and tell me in this definition which was the most important thing? So certainly, sir, it was relative motion because on the basis of relative motion only, we are identifying the links. So when we say the relative motion is the most important word here, so we need to talk about this relative motion also. Now I want to ask you something before I move ahead to this relative motion. Okay, before I move ahead with this relative motion, I want to ask you one question. Okay, so what do you feel? What is most important thing that we must ensure for a machine? किसी मशीन के लिए सबसे important चीज क्या है? What is the most important thing? Very good, Vishnu. Relative motion is the most important one. Now please answer me this also. बताइए, what do you feel what do you feel is the most important thing that we should ensure for a machine? किसी machine के लिए, for any machine, what according to you is the most important thing? Now, those students who are seeing the recorded lecture also, please answer it in the comment. Okay, I will read it later. After the session, I will read it later, and if you have the doubt, I will reply you back or will discuss in the next session. So, what is the most important thing you see for a machine? Please answer me this. Let's see what do you feel about it. So, we are surrounded by the machines. Okay, there is a dialogue of a movie also. Very famous movie. What's the name of the movie? I think Three Idiots. Okay, in that movie also there is a reference to this, that we are surrounded by the machines. So again, we are. If I say a machine to you, so many things must be coming. So many things are coming. So Vishnu, you are saying, sir, less input, more output. This is the most important thing. I would not agree to it. Anything else, I wouldn't say that is most important, that less input and more output. You are talking about efficiency. Now, first of all, there should be less input, that is true. There should be more output, that is also true. But before that, we must have our input and we must have our output. And always remember this output should be unique. This is the necessity. Efficiency will only be seen when there is a unique output to a machine. Don't you agree to me? I'll quote some examples. So all of us must have drove a motorcycle, cycle, car or anything. Now, is it right to call a motorcycle? Is it right to call a motorcycle a machine? Yes, sir. Yes, sir. It is very well. It is right. It is true that a machine can be called upon as a motorcycle can be called upon as a machine. Now, I want to ask you something. We have an accelerator on the motorcycle. So when we push the accelerator like this, when we do the accelerator like this, in our heart we know, now when we are doing like this, in our heart we know that our motorcycle is going to move forward. Is it or isn't it? Now I want to ask you this. If you are sitting on a motorcycle and you do not know that what is going to happen when I will do this to the accelerator, that motorcycle will be of any use. No, sir, I will use it. It should be economical. It should consume less petrol. Is this the first thing that you should ensure, or is this the first thing that you should ensure, that when you are pushing the accelerator, your motorcycle must move forward? Now, please answer. Can you use a motorcycle? Sir, we are using a motorcycle on which we are having some we are sitting on a motorcycle and we do not know. Sir, when we push the accelerator, we will get the surprise. हमें surprise मिलने वाला है. हम accelerator दबाएंगे, क्या होगा? We don't know. When we push the accelerator, we don't know what is going to happen to it. So, will there be any use of that machine? Do you agree to it or not? Yes, sir, definitely it should consume less fuel. But for that, before that, its output must be unique. This is what is theory of machine about. In the whole theory of machine, we'll be trying to do this. We'll trying to make the output unique. We will try to make the output unique. There can be n number of examples of it. Anything which is useful. I hope wherever you are sitting and watching me, there must be a fan in your room. So when you move up, when you move up, when you go and put the switch on, you always know that now, as you have pushed the button, now, your fan is going to rotate. You always know that output. Now, unless you know that output, unless that output is unique, there is no use of that fan on your room. Yes or no? Now, we must agree to this. Yes, sir. Now we understand that for a machine, the first thing that we should ensure that its output is unique. Now, I want to ask you one more thing. Now, as we have quoted for the fan, so when you move and go and switch on the fan, your fan starts to rotate. Isn't it the best thing that can happen? इससे बेस्ट कुछ हो सकता है क्या? Isn't it the best thing can happen? No, sir, what do you mean? No, I mean sometimes what happens in some places, what we do, we go and switch on the fan, but fan didn't start it. Then what we do, we take the pen and we go and we do like this on the pen. Sometimes when we are traveling in our Indian railways, this kind of a thing happens. You put the fan on, ठीक है, आप fan चलाइए. You go and switch the fan on, but it doesn't rotate. So what you do, you stand on the berth, you take pen out of your pocket, you put it on the wings of it, and you do give one more input to it. Then it started to rotate. Then it is working fine. Now, would you like to do the first thing? What would you prefer? You would prefer that, sir, when I am pressing the switch, my fan is getting on. Will you prefer this, or will you prefer to stand on the table and do like this? Then your fan starts. What would you prefer? I want to ask you, Vishnu, and anyone else, everyone else. So those who are seeing the recording also, I request you to do comment. I will read your comments, my dear. Do comment. क्या अच्छा लगेगा? What will be good to us? क्या अच्छा लगेगा? क्या हमारी चाहत होगी? What we will desire? Yes, sir. We love to give two inputs. We firstly go and switch the fan on. We then bring a table, stand on the table, and give one more input so that my fan can rotate. Definitely, all of you, if you are having a good state of mind. Now, some illogical things someone may say, sir, if we give the next input, it is sort of an exercise to us, so our body will get fit. Don't talk like that, no? If you want to have a fit body, go to some gym. Okay? Right. So definitely, Vishnu, as you are saying, so everybody will prefer the same. Sir, I will go. If I switch on the button, if I put the switch on and the fan is rotating, this is the best thing. Now, please understand this. So, if the input is also unique, understand this. If the input is also unique, so this is the most desired thing. But not the necessity. Unique output is necessity, but unique input is not the necessity. Getting my point, beta? Getting my point. So this is the best thing. This is the best thing. What is the best thing? So if for unique input, there is unique output, if for unique input there is unique output, nothing can be better than this. This is the best thing. But this is not the necessity. This is the necessity. Remember, very useful concept I am telling you. People are unable to understand the theory of machine. ठीक है. So unique output is the necessity and this is your desirability. ये आपकी चाहत है कि ऐसा हो जाए तो सबसे अच्छा हो. लेकिन this is not the necessity. Why it is not the necessity, my dear? Why it is not the necessity? Because when you are giving two input and finally your fan started to work. Now, isn't it now when your fan start to run, तो isn't it now start to serve its purpose? क्यों? जैसे हम बोलते हैं काम तो चल गया. Yes or no? Yes or no? Even after giving two inputs, you are getting the unique output. Now, can we say now we are having some utilization of that thing into question? As we have put the example of the fan, even you are giving two inputs to the fan, after that even the fan starts to rotate, so it is serving its purpose now. But if fan doesn't rotate, it cannot serve its purpose. Now you understand the necessity and desirability. Desirability is what suits us. But sometimes it is also required that we increase the input to get the unique output. Because unless we get the unique output, the purpose will not be served. As the engineer, as the designers, what we have to do, we have to take choices. Any subject you read in engineering, all we need to do, all is to be done. What is to be done? We need to take decisions. This is the duty of an engineer. Is to take decisions. Getting my point? Is to make something some purposeful. Right or wrong? So even when we are giving more than one input, if the thing is working, we can make some use out of it. But if the output is not unique, then the thing has no use. So in theory of machine, what we are going to do? So in theory of machine, so this was the first class. Now in every class you will feel that we are doing this. So in theory of machine, what we are going to do? We want this unique output. If not, there is no use of this subject or there cannot be any purpose that can be served. Getting my point? This subject is very, very important, my dear. This subject is very, very important. Understood? So when we say theory of machine, the purpose of theory of machine is to get this. By one input, if we can get it by unique input, then we have done our job beautifully. So when we say that the work is done and work is done very well, so when we say the purpose of this subject is served very well, when we can get this unique output by unique input. But if we are not getting unique input and unique output, still we can make the things work. As for example, sir, is there any example, some may say, sir, is there any example where there is unique output but not unique input? So there are a number of examples of it. One I quote you that we are going to see in the sessions also. Epicyclic gear train. There is something called as epicyclic gear train. Very useful. So in epicyclic gear train, we have two inputs. So in this, when we give two inputs, we get one output. So this is also there in theory of machine. But the preference will be this. Unique output is the necessity. If we get it from unique input, nothing can be best for it. Nothing more can be better than it. But even if we are not getting unique input and unique output, still we can make the things work. Okay? So beta, in this session we will be stopping here, and in the next session we will be starting with exploring the relative motion. So this is going to happen in the next session. Understood, my dear? This is going to happen in the next session, right? So please subscribe the channel if you are liking the videos. If you are liking the content, do subscribe the channel, so that you get the notifications also whenever some new video is coming. So every day so many subjects are running at a time, so please make full use of it. Absolutely free, no money will be required, you are not required to pay anything. Okay, you are not required to pay anything. Just do one thing, please subscribe the channel. Please like and subscribe the channel. So with this, I would say thank you very much, and we'll see you in the next session. Okay, we'll see you in the next session. I hope Vishnu will be finishing the term very well before October. October is very far away, my dear. Don't worry. We'll do it in very soon. Much before that. Don't worry. Don't worry, my dear. I hope we guys are liking the sessions. I just hope we are liking the session. Be punctual, be consistent, and definitely you are going to learn a lot of things from me. Okay, I will try my level best to deliver as good as I can. All right. So with this, thank you very much, and definitely I will see you in the next session. Please do not forget to like and subscribe the channel. Okay, so thank you very much.